Hello again and welcome to my channel Professor Learnwell. In the last video we looked at three-dimensional shapes. Three dimensions meaning length and width and depth. Another word for width is breadth. Thinking the swimming pool, you swim a width across the pool, you can swim a length along the long side, and the third dimension would be diving down into the depth of the pool. But in two-dimensional shapes we have just length and width. We don't have any depth because there is not the third dimension. We are just thinking of two measurements, the width and the length. Let's start off with the simplest two-dimensional shape, which is the triangle, which is made up of three sides. Tri meaning three, triangle, three angles. Every triangle, when you're considering the three angles, has a total of 180 degrees, and that is shared amongst the three angles. So whatever shape the triangle is, whether it's a scalene triangle, an isosceles triangle, or in this case an equilateral triangle, the number of degrees of turn will add up to 180. The special thing about an equilateral triangle is that it has equal sides, equilateral, meaning equal sides. The length of each side of this special triangle, they're all the same. And that must mean, in the way that the triangle is constructed, that the angles are the same. This sort of shape, when we're thinking from a designing technology point of view, just veering off the geometrical shape maths aspect for a moment, is a very strong structure. So if you look at structures often made of wood or metal, they're often, almost always made up of triangles, because you can't change the shape of a triangle once it's joined at the corners. But I digress. Let's go back to the geometry of this. So, and do you know the number of degrees in each angle if they all have to be the same and they all have to add up to 180 degrees? In this case, they are 60 degrees. So if we had a protractor to measure these, we'd see that each angle added was 60 degrees. And when we add up the three 60s, we get 180, as 6 3s are 18. So 3 lots of 60 make 180. And you'll notice this special sort of triangle is symmetrical whichever way we turn it. So we have the line of symmetry there. If we folded it, that would be a line of symmetry. And if we have it this way up and folded it this way, it would fold on itself, so that would be another line of symmetry. So there are three lines of symmetry on this particular two-dimensional shape. The other sorts of triangles are isosceles, where two of the angles are the same, equal to each other, but the third angle could be different. It could be acute, like these, or it could be an obtuse angle, which is more than 90 degrees. The way to remember acute is that this is rather a sharp point on these particular angles. And if you have an acute pain in your teeth, for example, it could be termed as sharp pain. So sharp, acute. Now, let's have a look at the next typical 2D or two-dimensional shapes. And both of these, I'm sure you know, are rectangles. They are part of the quadrilateral family of 2D shapes. Quad meaning four, quadrilateral, four-sided shapes. Rectangles are special because all the corners have the same number of degrees in their angles. In the way that a triangle's angles must add up to 180, in a quadrilateral and in this case rectangles, the angles always add up to 360 degrees. And in the case of rectangles, each angle must be the same. If they're the same, which they are, then if you divide 360 by 4, you'll get 90. Think of our times tables. 4 9s are 36, so 4 90s are 360. Let's start off with this rectangle first. The name of this rectangle is an oblong. To some teachers that might seem an old-fashioned word, but it's useful to describe this type of rectangle as an oblong. Then it differentiates it from the square, which we'll come to in a moment. This rectangle is an oblong because the adjacent sides, the next to each other's sides, are different. The word adjacent means next to, in the way that the house adjacent to yours or the apartment adjacent to yours is the apartment or house next door to you. These 4 angles, as I mentioned, are 90 degrees. The other word for a 90 degrees angle is a right angle. So let's add up the 4 90s and see if we get 360. 90 at 90 is 180. Add another 90 is 270. And the last 90 brings us up to 360. And the special properties of this 2D shape are that the opposite sides are the same length, in the way that the shorter sides are the same length to each other. Now, in a later video, we'll look at the shape called the parallelogram, which is also a 4-sided shape, another quadrilateral, but it's in a way tilted. But let's not confuse ourselves for the moment. Now, when we are looking at this shape, this is also a quadrilateral because there are 4 sides. It's also a rectangle because all 4 angles are 90 degrees each, adding up to 360. But the special property of this shape is that the lengths of each side are exactly the same as each other. The adjacent sides are the same. And so this special rectangle is called a square. And if we're thinking about symmetry for this shape, if you were to fold it this way and this way, we've got 2 lines of symmetry, one there, horizontally across the middle, one vertically there. But if we were to turn it slightly and fold it down, we'd see that we had another line of symmetry going from angle to angle, going diagonally across. So diagonally, diagonally, vertically, horizontal, 4 lines of symmetry. In this shape, there are only 2 lines of symmetry because we could fold it on itself this way or that way. I should mention, actually, in case I've caused confusion, that this particular equilateral triangle had 3 lines of symmetry, but if it's a scalene triangle where each side is different, there would be no lines of symmetry. If it were an isosceles triangle where 2 of the angles or 2 of the sides are the same length, but the third length and the third angle are different, then it would have only 1 line of symmetry. But this is something I will come on to later. Now, moving up from 3 to 4, and I mention at this point, there are no 2D shapes with only 2 sides. It wouldn't be possible to have a 2-dimensional shape with only 2 sides. They'd have to be next to each other, and so it would be a line, which is just 1 dimension. This particular shape is called a pentagon. In this case, it looks very much like a regular pentagon. And for it to be a regular pentagon, the number of degrees in each angle would have to be the same. And therefore, if each angle is the same, and it doesn't have to be for a pentagon, if they are all the same, then it's a regular pentagon, in which case we will have lines of symmetry. And to test whether a shape is truly symmetrical, if you fold it on itself like this and it overlaps perfectly, then you have a line of symmetry there. We turn it slightly and fold it this way. We can create another line of symmetry, and eventually we would create 5 lines of symmetry. So there's a bit of a pattern there in regular shapes. In a regular triangle called an equilateral triangle, we have 3 lines of symmetry. In a regular quadrilateral, the special rectangle called a square, we have 4 lines of symmetry. And in a regular pentagon, we have a shape with 5 lines of symmetry. Now, these angles will not be right angles, they are greater than 90 degrees. And if you wanted to be sure as to how many degrees there are, you would measure them with a protractor and multiply that number by 5, and you'd get the total number of degrees. But that's a little bit beyond our Key Stage 1 and Key Stage 2 descriptions at the moment. Pentagon, children often remember this being a pentagon. They usually find the 5-sided shape easy to remember. And there's a very famous building in Washington called the Pentagon because it has 5 sides to it. Moving up from 5 to 6, a 6-sided shape is called a hexagon. 6 sides. And in this case, it looks very much like a regular hexagon. And if it is a regular hexagon, then each of the 6 angles will be the same, equal to each other. In which case, each of the 6 sides will be equal to each other as well. You can have a hexagon which is not a regular hexagon. So any 6-sided 2D shape is a hexagon, but for it to be a regular hexagon, each angle must be the same. And again, as in the case of the pentagon, the number of degrees of each angle is more than 90 degrees. Remember that the special quadrilateral, this rectangle, the number of degrees in each of the 4 angles is 90, but in a hexagon, the number of degrees are more than 90. So you can see it's, if we were imagining the hinge of a door here and the door opened, because an angle is a degree of turn, that's almost 90 degrees, but it's opened a bit further. So it's not an acute angle. So it's not this sharp, painful angle, acute, remember an acute pain. It's not a right angle because it's more than 90 degrees. We call this sort of angle an obtuse angle. Obtuse. And this is a hexagon. 6 sides, 6 angles. Now, in terms of symmetry, if we were to fold this shape very carefully on itself, if there's no strange overlap, and it folds perfectly on itself, there's a line of symmetry. If we turn it slightly and try and fold it this way, it folds perfectly on itself. So those 2 shapes are the same. So that's the second line of symmetry. And if we carry on doing that, and you can try this at home if you have a regular hexagon, you will find in a regular hexagon there are 6 lines of symmetry. But it has to be regular for those lines of symmetry to be there. Some people use a mirror to check, but I always prefer to cut out the shape and fold it to be perfectly sure that there are lines of symmetry. If it's an irregular hexagon, then probably will be no lines of symmetry, but it would depend exactly. If these two shapes, these two sides actually were longer but equal to each other, it wouldn't be a regular hexagon, but there might well be a line of symmetry and possibly a second one. Each case is different. And the last shape we're going to look at for this particular lesson is an 8-sided shape, which most children always remember as an octagon. And they generally remember that because an octopus has 8 legs, 8 tentacles. And this has 8 sides and 8 angles. And in this particular example, the sides are at equal length, the angles are equal degrees of turn, and so this is a regular octagon. And if you were to fold this very carefully, you would find there are 8 lines of symmetry. That's all for the moment, looking at 2-dimensional shapes. Thank you for listening. I hope you found that useful. And if you do have any questions, please do ask them in the comments box and I will answer them. And if you found this useful, please click like and subscribe. And do contact me if you have any other areas of maths or English you would like me to explain. Thank you for listening and goodbye.